you, and excited to make the acquaintance of others that I haven't met yet. So I'm going to give a few minutes for people to get connected in and be participating in the webinar. Cale's handling some comments and questions on the back end, and so he'll be one typing away back there. I'm not on the keyboard. I'm just standing here talking. I've got some things to show you. Two critical things that are going to get us through this. One is coffee, and the second is I brought my notes. I don't know about you, but for us here in the Pacific Northwest, fall and getting into storm season, we get big wind, big rain starting in October, November, into December, and we are so incredibly busy. So I've been a little rain fried. I made some notes, and my wife made some coffee, so this should go just fine. I know I'm a little bit blown out in the light here right now. Don't tell anyone, but it's not actually raining in Seattle. It's perfect out around. I think it's almost completely blue sky, about 52 degrees, 54 degrees. I was planning for rain, so we're actually here on my back deck. This is my yard behind me, and we're covered over in case it does rain. So today we're going to talk about rigging, and I think Nick Bonner, thank you to Nick Bonner, I think build this as a rigging demo. The title that I prefer for it is Rigging, Dial in the Details. What I mean by that is we think a lot about rigging in terms of the big picture and how many rigging points and what's the size of the piece and how big a rope do I need. But when do we really talk about the details? When do we really talk about the whys? When do we talk about sort of the theory behind it and deciding which knot is appropriate, what rope construction is best, what kind of connecting link makes sense for this application or that application? And so today we're going to spend about the next 2 hours together, and we're going to try to dial in the details. Some of that's going to be me talking, but I'm hoping that we get some really good questions from you out there. Cale will be collecting questions, and then he'll help kind of feed them to me, and we can respond to them. And I want to get you as much information as we can. And I didn't invent any of this. I'd love to say that I did, but I didn't invent any of this. I just use it a lot. And I've had the opportunity to participate and to lead a whole bunch of training with arborists around the country and in a number of different countries as well. And I'm always intrigued by the questions, and I'm intrigued by the challenge of rigging and learning how to do it better, sharing that, and then learning from the great questions that come up. That's really motivating and inspiring to me, and I enjoy paying it forward, sharing knowledge. So I'm hoping that today I can do that for you, and that this will be a valuable time spent. I know it's late in the evening out in the East Coast. I think it's the middle of the night if you're in Australia or Malaysia, or maybe it's tomorrow morning. Is that Friday already? I don't know. But anyway, thanks so much for being here. And I think we're ready to get started. I'm just going to communicate with Cale. I've got a little earpiece in. Cale, I don't think you're muted back there, buddy. No worries. So, all right, Cale's going to mute his mic. And we're going to go through 4, 5, 6 major topic areas. And we'll take a few breaks in between. And please put together questions as you hear things that don't make sense or you want to know more. Please submit your questions to the comments, sort of facilitate that, and we'll take some dedicated little breaks for questions. All right, so let's get started. And I want to start with big concepts. Big concepts. We got to use the big concepts voice for that. What are some of the big concepts that are key to me thinking about rigging, thinking about making a good plan? One of them is the idea of planning ahead. You know, typically we don't plan to fail, but sometimes we fail to plan. So planning ahead is one of them. But what's really interesting is, if your experience is anything like mine, you make a plan and then you change it a little bit. There's always something new. From the ground, the tree looks one way. From up above, it looks like something else. Maybe you see a new target. Maybe you see an included union that you need to protect. Maybe there's some deadwood, or maybe the tree leans a little bit one way or another in the upper canopy that wasn't visible from the ground. So make a plan and be prepared to adjust. That's a key concept for me. Big concept. Another one is thinking about when I'm going to remove a tree, whether it's my crew or I'm subcontracting with somebody or out on a big project where we're going to remove a tree, thinking about the most efficient and safest way to do that. And I really think about it in an order of priorities. And so here they are. There's 4 of them. The first one is, can we fell it? Can we lay this tree down whole? Is there space to do it? Are there targets that we need to consider? Is the condition suitable? Is the tree going to fit with some margin for error? And do we have the skills within our crew and equipment needed to lay this tree down whole? That's my first option. If we can remove a tree and we can fell it, by golly, let's do that. That's often the safest way. If we can't fell it, the second option is to free fall. And what I mean by that is a climber, or maybe from an aerial lift, a bucket truck, be up in the tree, and we're going to cut and free fall pieces. We don't need any ropes. If we've got a good landing zone, we don't have to worry about a target underneath. You know, the yard is in a condition that we can drop material onto it and not worry about it. By all means, let's free fall material. So that's the second option. Third option is rigging from above. And let's be sure we're clear what we mean. Rigging from above, if you look over my shoulder here, it's probably hard to see, but I've got an Omni block set up there. If I'm rigging from above, here's my load. Here's the fall of the rope, the lead. My load is on the lead. If I can rig from above, I have a lot of control. We can have a very static type, low energy rigging system, and we can safely lower material. Rigging from above is something that often happens when we're removing low limbs, perhaps during a pruning activity, or maybe it's going to happen early in the removal of the entire tree. So let's figure out where we are in order. Can we fell it? Can we free fall it? If we can't do those, maybe we can rig from above. And if not, our next option is to rig from below. Why is rigging from below the last option, the last of those four choices? It has to do with energy. If we think about blocking down a bar or taking the top off of a large tree, the block itself with our sling is below the piece that's being rigged. And so what do we have? We have more energy when we are rigging from below than if we're rigging from above. We have more energy, we have more risk, and that's why rigging from below, some people call it negative rigging or negative block rigging, that's our fourth choice. So one more time, can we fell it? Can we free fall it? If not, let's rig from above. And as a last resort, we can rig from below. That big concept, right? Use the big concept voice. That train of thought leads us to making good decisions as we set up our rigging tools in the tree and set up our rigging system or our rigging concept as a whole as we're planning our work. Related to that, I'll share something that was given to me sort of as a gift of an idea early on, and it's really stuck with me. And that is when we are rigging, that our rigging should get easier through the day rather than more difficult. In other words, we're going to set up our rigging with the end in mind. Maybe that's taking out the top, or maybe that's rigging down wood. And we're going to work from what is more difficult back to an easier scenario. And we're working back into where our rigging point is set. So we'll maybe set a high rigging point over here that we know is what we want for the end of the day, and we'll redirect over to another portion of the tree and do this part first, and then work our way back toward our primary rigging point and then down the stem from there. The concept being that the rigging gets easier through the day rather than more difficult. Another big concept. Big concept. All right. We have to know the load. We have to know the force. So we're going to use a few different terms today, and I'm going to do my very best to be clear with them. And sometimes I screw up and use them interchangeably, but they're different. So here are the terms. The piece. The piece is the material. Maybe it's this log. The piece that we are rigging. Maybe it's a large piece of canopy. Maybe it's some trunk wood, whatever it might be. The piece is what we're going to put onto the rigging line. The second thing we're going to use is a term that is, I use the load. How much load, how much force? I'm going to use those a little bit interchangeably. How much load are we putting into the system? And let's do a little demonstration of what we mean. All right. So our piece has a weight or mass of, what is this? Let's say 10 pounds. It's easy math, right? If I just hold this piece in a static configuration, or I rig it from above, and it stays still, I'm not lifting or lowering, the force is roughly equal to the load, or excuse me, equal to the piece weight. But as soon as we introduce dynamic movement, all of a sudden, we have force that's greatly increased relative to the piece weight. So you'll hear me use load and force together. The piece is the item being rigged. The load or the force in the system is something that is created or managed due to movement. All right, so some terminology there. As I think about the idea of piece weight versus load or force, think about making good decisions, I'd like to share a story with you. A number of years ago, I was doing some subcontracting with a good friend of mine out on one of the islands here in Puget Sound, working on a fairly good-sized conifer. Been working together a number of days, and we were finishing up on this one particular tree. We had rigged out a number of limbs. We were, we had taken the top and a few pieces of wood, and we got to the point where the wood was relatively large. We switched to a larger diameter rigging line. I don't recall the diameter, it doesn't matter, but we switched the line, so the dynamics changed a little bit. And this is one of those things where dialing in the details, something we could have done better. So here's what happened. I'm up in the tree, I've been cutting wood, negative rigging it, right? Rigging from below, that was my choice at the time. We got to this next piece, we switched to a different rope, got the block in place. I called down to the person running the rope, hey, put on whatever it was, 2 wraps. We were using a porter wrap style lowering device. And the rope handler put on those 2 wraps, pulled it tight and was ready, and stood back and was ready to hold the porter wrap, right? Holding the rope, ready for the piece to come down. I made my face cut, back cut, pushed the piece off. And I distinctly remember watching the piece come over and start to dive a little bit. And that's fine. We're going to let it run. We're going to dissipate some energy that way. And out of the corner of my eye, I could see the person handling the rope. And they had leaned back like they were water skiing. If you've been water skiing, right? They're leaned back on this rope. And all of a sudden, they go from leaning back to leaning forward. And in the blink of an eye, they are horizontal like Superman. And I saw the piece coming down out of one eye, and I saw the person flying across the job site from the other. And that moment has stood with me. And what that was is that was, like they say in the movie Cool Hand Luke, that was a failure to communicate. We misunderstood each other about how much friction was needed and the size of the piece. We did not have our details dialed in. And all's well that ends well. Nobody was hurt. We were both shaken up. It was a scary experience, and it's something I've never forgotten. And it's really made me diligent about communication on the job and getting all the details right before we start moving large pieces of wood through the air or do any rigging. So that story sticks with me, and some of what we're going to talk about today comes directly from that experience. All right, so the load we talked about earlier is a function of the piece, both its dimensions, its length, as well as its weight, and the movement, how far it's moving. All right, and there's a multiplication. And I'm going to give you really simple math. Not a lot of math today, but this is part of it. So if we have the weight of the piece and it moves 2 feet, the way we're going to calculate the force, tree guy math here, right, is the weight times the number of feet plus 1. So if this weighs 10 pounds and it goes 2 feet, 2 feet plus 1 is 3. So 10 times 3, we get 30. So we took a 10-pound piece and created 30 foot-pounds of force or load. So some simple math to remember. If you have dynamic rigging, if a piece is moving, take the distance it's going to move plus 1 times the weight. And that will give you a rough estimate of the force. And where does that come in? Why is that so important? Well, one, anytime that we're going to move an object through the air on a rope, either lifting it or lowering it, we really need to have an understanding, at least of the magnitude of force we're talking about. Are we talking about 100 pounds, 1,000 pounds of force? Or are we talking about 10,000 pounds? All of them are achievable in rigging in trees. 100, 1,000, 10,000. We can achieve all of those whether we want to or not. And when you're out there performing a removal and communicating with your crew, setting up your rigging plan, choosing your materials and your hardware, you got to have a good sense of what that force is going to be. So, something to think about. And where does that lead us? That leads us to rope selection and hardware. And let's talk about a little terminology first. I've got a block here in my hand. So a block, arborist block, designed for an impact load, designed for dynamic rigging. You've probably seen pulleys that might look similar. Pulleys often have moving cheek plates. They're not designed for impact loads. They're not designed for dynamic rigging. What we're going to talk about today is we're going to talk about rigging with blocks and dynamic loads. So on this block, we've got a couple of ratings, and you probably can't read them, so I'll read them for you. Down in here, the minimum breaking strength is listed as 100 kilonewtons or 22,480 pound-feet. The MBS, minimum breaking strength. That comes from the manufacturer based on their testing methodology that over a series of tests, they found that this designed piece, this engineered manufactured piece, the minimum point at which it broke was 100 kN or just over 22,000 pounds. Well, that's good to know, but maybe it tells me something that's not terribly pertinent to my work. So on here, there's another designation or another characterization, a WLL, work load limit. Let me say that again. Load limit. And this is listed as 20 kilonewtons or 4,496 pound-feet. So I'm going to call that 4,500 because it's easy math. And so let's compare the minimum breaking strength, 100 kilonewtons, working load limit, 20 kilonewtons. The difference between those numbers is really important. That is what we call a design factor, or some people call a safety factor. I prefer the term design factor. The design factor is 5 in this instance, or 5 to 1. That working load limit, which is the amount of force this piece is designed to take in regular operations without fear of failure. Working load limit is the amount of load or force this item is designed to handle in regular operation without fear of failure. Is 1/5 or 5 to 1 relative to the minimum breaking strength. So our minimum breaking strength, 22,000 pounds, plus or minus. Working load limit, 4,500 pounds. And so what does that mean for us out in the field? When we are thinking about the load, remember our piece here, the load we're going to put into the rigging system, we want to be within or close to the working load limit of our hardware and our textiles, our ropes, slings, etc. Not the minimum breaking strength. I want you to consider for a minute this concept. Big concept, right? So if we load this block 100 times, 1,000 times, 5,000 times over its lifespan, we can load it many thousands of times within that working load limit. What was it again? 4,500 pounds or 20 kN? If we load this repeatedly around that working load limit, we can use this for a very, very long time with a high level of confidence and without fear of failure. As soon as we start loading that heavier and heavier and heavier, and we start approaching that minimum breaking strength, the number of cycles before this device fails dramatically. From a theoretical standpoint, we maybe could load this one time at its minimum breaking strength with 22,000 pounds. We could probably load it one time, and the second time, maybe it's going to break. That's not any way to operate either a piece of equipment or in a hazardous profession like arboriculture. So these, whether it's a block, any piece of hardware, textile slings, are all rated with a working load limit. and a minimum breaking strength. That working load limit, that WLL, is what tells us the amount of force that item, whether it's a block, a rope, whatnot, is designed to sustain repeatedly in regular operation. So working load limit, that's the number you want to be looking for. When we talk about dialing in the details, I want you to understand that when you look at a piece of hardware, you know the difference between MBS and WLL, between minimum breaking strength and working load limit, and why those numbers are different and which one to look at. You want to look at that working load limit. Remember then, just like we've talked about, we need to balance our textile, our rope, with our block, and with our sling. I just happened to pick these up off the table. I couldn't tell you whether they're balanced, but I feel pretty good about it. So we've got a block designed for 5/8 inch rope. We have a 5/8 inch diameter rigging line, and we have a 3/4 inch diameter sling. Now, wait a minute. Why is the sling diameter, hey, that's the sling. Why is the sling diameter and the rope diameter different? I want you to think about that for just a minute. When you're setting up a rigging system, why would you have a different diameter sling at the block than your rope diameter? Let me say it another way. Why would you have a larger diameter sling at the block than your rope diameter? Let's think about how rigging works. When we have our block suspended in the tree, we have our load on one end, and we have our friction device, our lowering device on the other. What does that mean? I bet you know that answer. It means force. And if our legs of rope, our parts of rope are parallel, and we have a low friction rigging point, we are effectively doubling the force. So our rope may be rated, have an appropriate working load limit for the piece and the type of rigging that we're doing, that force we're expecting. And we have to make sure that our sling is going to handle potentially double that load. So the important point here, the sling on your rigging point, on your primary rigging point, needs to be larger diameter than the rope, because it will see more force than the rope will. Just as your block needs to be rated appropriately. It's dialing in the details. It's all these little things that are so easy to forget about, or maybe just not think about in the first place. Now, I can't see all of you, but I want you to think for a moment. Have you ever been given a kit of rigging gear and said, well, I guess that's what we're using when you head out to do a removal? I know I have. You know, if you have, raise your hand too. I can't see you. But we've all had that. Here, this is your gear. Go get it done. Oh, hey, Kale's telling me we can hit the like button. So let's do that. Hit the like button if you would. How many of you have ever been given a bag of rigging gear you were unfamiliar with as you were headed out to do a removal? And you get to the job and you open it up and you go, well, I guess that's what we have. Hit the like button. I'm doing the thumbs up for the like button if that's happened to you. And Kale, why don't you let me know when you have that feedback? How many? Is it everyone? I'm going to guess it's everyone. All right, so we have 175 people in our webinar. I guess I'm 176. Cool, that's awesome. And how many do we have who have had that experience of sort of the mystery rigging bag, and you open it up at the job site and you go, well, I guess this is what we're using. What are we at so far, Kale? Lots. Okay, Kale's going to get me the answer here in a minute. All right, so we've all been down that road. And what I want you to be able to do with these details that we're talking about is when you open a bag of rigging gear, hopefully at the shop rather than at the job site, you can look at what you have and say, here's the block, here's the working load limit. Okay, that's a limitation. What's my block sling? What's my rope? How do these fit together? And if you have a rope that you don't recognize, whether it's this size or that size, we got to find out what that rope is and what it's rated for. Because then we understand what our working load limits are. Unlike hardware, textiles usually don't have that marked on the rope. Now, there are a few companies out there that I am endlessly impressed with that have tags on all their equipment, on their rope bags, whatnot, that identify the age of the rope, the construction, the manufacturer, the date put in service, and the working load limit. I commend you. If you have that in your company or in your own personal kit, good for you. I'll tell you honestly, I do not, but I'd like to. It's a great way to know what is this rated for or that, and does it fit with my hardware? So dialing in these details and looking carefully at what we have as we set up our rigging systems. Because remember, we can always cut pieces smaller to accommodate lighter weight tools. Sometimes we have big tools like 3/4 inch rigging line that we can cut pieces larger. We have to know what we have, know that it's in good condition. Proper inspection is really important. And then we can modify our plan to do that. So one of the tools I want to bring up, speaking of details, is a green log weight chart. If you haven't used one, find one. Order one. I'm sure TreeStuff sells them, right? Get a green log weight chart. And what it has is, I want to say, about 100 or so common species of trees and log weights by diameter in a 1 foot length. So it would tell you that this Pseudotsuga menziesii, Douglas fir, coastal variety, not Rocky Mountain variety, in, what is that, 6 inches diameter and a 1 foot length, let's assume it's a foot, weighs, well, I'm going to guess, 11 pounds or 12 pounds, something like that. But it would also give you what a 14-inch diameter piece weighs, and a 16, and an 18, and a 20, and a 32, and a 48-inch diameter piece. And then you can do the math. So you can figure out what your piece weights will be, and or back your way into that saying, this is what our rigging is rated to. This is our working load limit. Here's how we're going to perform the rigging operation. This is our piece weight limit in that type of rigging. There's all these details. So a green log weight chart, super important. I keep one in my clipboard in the truck. Before we're going to do a rigging, particularly negative block rigging, rigging from below on the spar or crane work, super important. I want to take measurements. I'll take a diameter tape. I'll take some measurements, and we'll understand what our diameters are. I'll call down to the crew on my Sena, on my Bluetooth, and we'll figure it out. I don't take the log weight chart up in the tree, but somebody on the ground has a clipboard that can tell me, hey, that piece at 30-inch diameter, each foot weighs 123 pounds. Okay, great. Well, if we take 10 feet, that's 1,230 pounds. What does that mean? And it's going to be dependent on the scenario, but great tools are available to help you estimate the piece weight. And then you can do that simple math, distance of travel plus 1 times the piece weight. And you can start to work your way through some simple math and get that rigging dialed in within the working load limit of your equipment. Hardware, textiles, sling, lowering device. So I told you this is going to be details. We're doing details. All right, so 2 more little bits, and then we're going to have some time for questions. First one of my favorite sayings in rigging: violence is not the answer. It's a funny way to say it. The other way to say what I was thinking is slow and smooth. When things happen quickly, abruptly, violently in a rigging scenario, bad things happen. It makes me nervous. At the other end of the continuum, when something happens smoothly, it's slow, it's controlled, the piece goes just where you want, you can adjust a little bit as the piece is being lowered, that makes me feel really good, whether I'm the one running the rope or if I'm up in the tree. So in rigging, violence is not the answer. Slow and smooth gets things done efficiently and safely, protects your crew, and prevents property damage. All right, last one that I want to bring up right now before we take our break for questions is that friction is your friend. Friction is your friend. Whether you need friction in a lowering device, whether it's a Porter wrap, a GRCS, one of the Stein products, friction is your friend for lowering. Maybe you're adding friction with a ring or a natural redirect in the tree. Friction is your friend. And why is that so important? I think back on my own experience. When I was learning about rigging, Man, I was under the impression somehow that I wanted the lowest friction I could possibly create, right? And what does that end up with? That means I need more wraps on my porta wrap. That means there's more movement in the system. It makes lifting easier, but lowering can be more challenging. So friction is your friend, and managing friction, we'll talk about a little bit later. Managing friction is what makes rigging go smoothly, getting the friction dialed in just the way you want it. All right, so if you haven't done it and you have questions, please send those in to Kale. Send them in, type them into the comments field, and let's take a short pause. And Kale, do we have questions yet?
All right. Hi, Craig. I do have a couple questions here. Let me find it so I can put it on the screen. This is about the WLL. Jay Bradley is asking, there's a little bit of a discussion, is the WLL only good for the first use of the rope?
Oh, that's a great question. That's a great question. And Jay, thanks for asking. I think what you're asking is, once the rope is used, it's dirty, it's wet, is it no longer valid? Let me try to answer the question as to the best of my understanding. I would be really interested in what a manufacturer's rep would have to say, whether it's from Teufelberger or Sterling or New England or whomever, Samson. To my understanding, the minimum braking strength and the working load limit are based on testing done with new unused rope fiber, because that provides consistency. So I think the straight answer to your question is that number is accurate specifically for a brand new rope. The concept of that safety factor, you'll remember, whether it's 5-to-1, 7-to-1, sometimes it's 10-to-1 for life safety equipment. The concept of that is that the rope, we anticipate that ropes, any hardware, any textiles will be slightly degraded over time. And by having that safety factor, let's say it's 5-to-1 like we had on the block or on a rope, gives us room that as long as we stay around that or within that working load limit, we can use the device with confidence, or use the rope with confidence. Once the rope is damaged, right, if we have strands cut, if we have a lot of glazing, if we have chemical contamination, that rope needs to come out of service. But for something that's been properly maintained, properly used, the working load limit should still be a good guideline for the force that can be introduced and safely managed by that product. I hope that answers your question, Jay. Thank you. What else, Kale?
I think that's a great answer. I have another one here that's very much on the same. I pulled the wrong thing up on the screen here. Sorry. Very much on the same vein of questioning. Aaron Rickenberg is asking, if a rigging line is free from cuts and abrasions and any glazing, how long do you use it before retiring it to a pole line or the kids' treehouse? So, like, is there a lifespan that we're looking for?
That's a great question. So I'm going to answer, Aaron, using two examples. These are two ropes. Actually, all the gear you're going to see today is out of my personal rigging kit that we use for the company. None of these are, training dedicated special ropes. This is all stuff that I use. So we've got a 3/4 inch Sterling Atlas rigging line, and we have an 11 mil HTP Sterling rigging line. The blue rope, the Atlas, is older than the orange HTP. I don't know if you can tell on camera, but the HTP has significantly more wear. So I would say that time, calendar time, is probably not the best way to measure it. I would measure it based on the amount of use and the condition. That 3/4 inch line, I probably use 2 or 3 or 4 times a year. When I need it, it's absolutely the right tool. And that rope could last me 3, 4, 5 years, no problem. That HTP, I use that in all kinds of rigging during pruning operations. We do a lot of tree preservation, and so when we're taking out large deadwood, we're lifting limbs over a house for roof clearance, I use that rope 3 or 4 days a week sometimes. It gets far more wear. And so I'm not sure there is a good answer for time. Certainly, once you get to 3 years or 5 years, I would consider replacement of the rope, possibly regardless of condition. But condition, inspection is going to be your first indication that the rope needs to be replaced. That said, like I would hope you have with your personal protective equipment, it's great to have a list of all your rigging gear: rope, length, manufacturer, date put in service, who used it perhaps. And once you start to see that you're getting to 3, 5 years, maybe longer, just plan to replace it. Because by that time, you've gotten your money's worth. Or it turned out you didn't need it in the first place. So I realize that's a bit of a roundabout answer, but again, condition and inspection is what's going to drive replacement rather than calendar time. Great question. Thank you very much.
All right, you started on that, and I've got a lot more really good questions popping up here.
Please.
One, I think we'll wait until the friction section that you're going to be talking about, but just getting it out there into your mind. Blair Glenn is asking, how does wet weather affect friction? So I know you're going to be talking about that in a little bit.
It's a great question.
The other one I have here, why do we use weight times distance plus 1 rather than force equals mass times acceleration?
Ooh, why do we use weight times distance plus 1 rather than force equals mass times acceleration? The simple answer is that acceleration, being gravity, being 9.8 meters per second squared, makes my head hurt. It's a bit of a silly answer, but it's mass times acceleration, far more accurate, far more scientific or precise way to calculate force. Weight times distance plus 1, far more tree guy-esque, right? It fits our treeometry kind of math. It's something I feel like I can do quickly in my head when I've been in the tree for 4.5 hours and I have a 66 on my belt and I am tired and I need to be doing things in a simple and consistent way. Okay, this piece we estimate weighs 500 pounds. It's 10 feet long. Ooh, there's a secret in there we ought to talk about. And it's going to go 10 plus 1 times 5. I get 11, 500. Whew, that's hard math there, but I'm going to guess that makes 5,500. So why do I say it that way? Keep it simple. Mass times acceleration, much more scientific way, and I commend you if you can do that math in the tree. But when we start getting into pounds and feet, the conversions just kind of make me cry. So I prefer to keep it simple, but you're exactly right. Mass times acceleration works. And let's go back for just a second in terms of calculating fall distance. So when we rig this piece, say our block is right here. Where's my block? Our block is here at the base of the piece. I'm going to use easy math. Let's say this piece is 10 feet long. The center of mass for this piece, if it were in a completely static system and flipped over, the center of mass would have started 5 feet. Imagine this is 10. 5 feet above my block, and it would end up 5 feet below. Totally static system. So coincidentally, that 5 foot above to 5 foot below, 10 feet, is the same as the length of the piece. So a little bit of simple math. The length of the piece plus 1 times the weight. For a negative block rigging in a spar scenario, it's pretty simple, and it's sort of a worst case scenario too. Because we all know that when we are rigging from below, whenever possible, we want to let it run. We want to absorb some energy, not have it locked off. So that distance plus 1 times weight sort of calculates that worst case number. And we say to ourselves, what happens if it doesn't run? Well, that's what might happen. So anyhow, that was an excellent question. We went down the rabbit hole a little bit. Thank you very much.
Okay. Let's try to do a couple more here before we go on. I have, let's see, which one? Are you going to get into natural crotch rigging versus pulleys and riggings and your friction and your rope selection there at all?
We're going to talk about it briefly. I don't know if we'll go super deep, but we'll talk about it. Yep.
Recommendations on when to replace friction devices. I think we can get into that in a minute here. Here's one that might be useful. If I'm negative blocking a 10-foot length and the block is 1 foot below the bottom of the spar, since the piece inverts as it falls, how far do we say that it falls?
Ooh, that's a great question. Thank you, Matt. And I'm going to answer it this way. 1 foot one way or another does not make a difference. Now, to more specifically answer your question, if it's 10 feet plus 1, call it 11. If it's 10 feet plus 6 inches, 10 feet plus 14 inches, call it 10 or 11. In the end, we're looking at something like 5,500 or 6,000 or whatever the number might be. The goal with this is to get close, right? This is not architecture. This is not calculus. We're moving wood through the air with a rope. So get into the ballpark. And what I really want you to come away with it is when you're standing up there in the tree or when you're running ropes on the ground for the new guy up in the tree, you both have a conversation about what that piece weighs and the kind of force you could be putting into the system. And you make darn sure that that's within or around the working load limit of your textiles. And that's what I really want you to take away. It's a great question. Don't get lost in the weeds.
All right. Let's do one more. What about ropes used for speed lines? We're talking a little bit about the WL and the lifespan here. If you lower big and heavy logs at a big angle, there is tremendous tension on the guide rope. Is there a universal rule for your proportion of anchor point and speed line rope? I guess what he's trying to get at, from what I can understand here, is when you are running a speed line, how do the forces work on the rope when you're dropping that with those angles?
Oh, that's a great question. Thank you, Martin. Let me see if I can briefly answer it. And part of it's going to be sending you in a direction for more information. Let's do a really simple demo of it. So imagine this is a speed line, right? And I'm going to send a piece down it on some sort of hardware connection. This happens to be a Pinto pulley, but doesn't matter. When we're going to run a speed line, the load that's created in here primarily is on the anchor points, whether it's a ground anchor or the anchor up in the tree. It's not necessarily on the center of the rope. And so the question becomes, how is your rope terminated at those anchors? Is it on a porter wrap? Did you tie a butterfly or a figure eight? How is the rope terminated? Because if you've tied a knot, that's the weakest point. Because the multiplication of force that's happening with load in the center of the rope pulling on the anchor, that's where the grade is going to be seen. At least that's how I would evaluate it.
Oh, hey, there we go. Okay. Wait, let me go back. All right. Sorry about that, everybody.
Hey, welcome back. Technology.
Okay, cool.
All right. Hey, so we were just finishing up on Martin's question, and the place where I would send you for more information, everybody, is one online, looking at angles and force vectors. The second is there's a wonderful tool. Now, it's something you'd pay for. Maybe you know somebody who has it, called VRigger. It's a program that is designed to calculate load forces in rigging applications. So go online, do some searching there, and then VRigger is a wonderful tool where you can set up anchor points and ropes, add forces, change friction. It's a wonderful tool. Taylor Hamill shared it with us at a training a few years ago, and it's stuck with me. So I don't have a copy of it, but maybe you know someone who does. Great question, Martin. I know I gave you a bit of a short answer, but thank you for asking. Okay. All right. Can we keep rolling and then take a few more questions?
Yep, I'll write down some of these, and we might be able to get back to them.
Right on. Cool. Well, we're starting to talk a lot about ropes, and it's really important to understand that every rope behaves differently. It behaves differently. So let's get a few samples here. Let's see. We've had HTP. I'll get a piece of that. This is 5/8 Samson stable braid. And here's our 3/4 Sterling Atlas. And let's get one more. This is 1/2" HTP. So manufacturer, not particularly important. That's not what we're trying to talk about. And I'm not here to recommend one rope to you or another. But these are all out of my kit. I actually have a 9/16 as well. And the question might be, why do you have so darn many ropes? I've asked myself that same question. But what I find is I really like being able to tailor the rope to the application. If I'm doing a very, very large tree that's spreading, I might start with my HTP, either in a 1/2" or 9/16, because I'm going to be rigging from above, and I want a very static line that I can use to lift and then lower. As I get into wood in the center of the tree, I may switch to a much larger diameter rope, maybe 5/8, maybe 3/4, that absorbs a lot of energy, because we're now in a dynamic rigging situation. And so choosing a rope, not just by diameter, but by a characteristic or behavior of the rope, enables me to tailor my rigging and accomplish most effectively what's important to me. And so we're going to talk about two basic kinds of rigging. One is, we talked about it earlier, rigging from above. And I'm going to use the term static rigging. Static rigging, where we're going to cut the piece. Here, let's do this. We've got our rigging set up. In static rigging, we're going to cut the piece, tying a cow hitch here. Well, let's get a little more rope into that. Piece is a little bit light. All right, we've got our cow hitch tied. We're going to cut the piece, and it's just going to hang there. We're rigging from above. Our goal is to limit the amount of movement and limit the amount of force in the system. The piece it hangs in place. We can move it easily, manipulate it down through the tree. So static rigging, rigging from above, those terms go together. So static rigging. The other kind we talked about earlier, dynamic rigging, rigging from below. So in those two applications, I want a different rope. And if we put aside the working load limit, the minimum breaking strength, the rating, and we just look at rope behavior, there's two very different behaviors here. And let's actually use these examples. Let's use 2 1/2" ropes and talk about how they are similar or different. And again, this isn't about one manufacturer or another. This is about rope construction, fiber, and characteristics. So these are both 1/2" ropes. HTP over here, and honestly, I don't remember if it's Dinosaur or Polydyne, but either way, a double braid polyester over here. So what's the intentional difference between these? Why would I have both of these in my kit? They're both 1/2". They're the same, aren't they? They're not the same at all. So HTP or other very, very static rigging lines, excellent for holding a piece in place, lifting a piece, because it has very low elongation. And the elongation happens very early in the loading. So let's clarify those terms a little bit. Elongation, meaning the amount the rope, well, I'll use the term stretches, but please take that with a grain of salt. The amount it stretches when a load is applied. HTP, I looked it up, in 1/2" stretches something like plus or minus 2% at 10% of the minimum breaking strength. So at 1,000 pounds, it stretches maybe 2-ish%. It's not very much. That's 2 feet over 100. A rope with much higher elongation, like this, may stretch 3 or 4 or more percent at 10% minimum breaking strength. So still within our working load limit, I might get 4 or more percent elongation out of one line and only 1 or 2 here. And what's interesting, when the elongation happens. Anybody who's ever climbed on HTP has experienced this. When you're ascending off the ground, you take your first few steps, you sit down in your harness, the rope elongates a little bit. Great. And then you start walking your way up your rope with your foot ascender, your knee ascender, and that thing feels like a steel cable because you've already taken the elongation out of the rope. The elongation is over, that is past, and now you're feeling an extremely static rope condition. Whereas if you were, you wouldn't, but if you were climbing on a rope more like this, some other more traditional climbing lines, 16 strands are a bit like this. If you climb on that and you're going up in a stationary rope configuration, you get a lot of bounce. It's not very damp. It doesn't feel very static. It's because you haven't taken elongation out. You haven't crossed through that elongation yet. And so it's still elongating, it's stretching and contracting as the fibers move in the braid. So to summarize, the rope behavior, one, low elongation early, such as HTP, great for lifting, great for static applications. A more dynamic rope absorbs more energy. It elongates more, but that elongation is energy absorption happening. Much better for dynamic rigging from below. So let's say it one more time. If I'm going to rig from below, I want a rope with energy absorption, and often that is elongation. If I'm from above, and particularly if I'm going to lift, maybe with a GRCS, maybe with some other mechanical advantage, I want a rope with very low elongation, and ideally one that elongates very early. And I'll share a quick story with you. I was doing a rigging demo a number of years ago, talking with a crew about GRCS use and some proper techniques, and we were just using their rope. We'd set it up through a block. We had a piece standing, had it tensioned, locked off. We made a snap cut on it, and we were going to lift it and break it. And I'm talking with them as I'm cranking away on this GRCS, and I'm clearly taking up rope. I can see it turning on the drum. The rope seems to be moving, and this piece is doing nothing. I was on a high elongation dynamic, more dynamic rope. It's not technically that way, but a more dynamic, higher elongation rope. And it took me 2 or 3 or 4 times as long as I ever expected to break the snap cut cranking with the GRCS because I had to pull all that elongation out of the rope. I had to get up. So I had to put so much force on before it transferred to the piece because it was elongating the rope rather than using something that is much more static, and it would have transferred that load much more efficiently. So choosing rope has to do a lot with the characteristic of the rope, the behavior of it, not just the diameter. Because these two have roughly the same working load limit, but they're going to behave very, very differently. So when you're choosing a rigging line, look at the characteristics, not just the diameter. Now, let's talk about diameter and how does diameter impact working load limit. All right, so let's compare 2 ropes. We'll use these 2 again. All right, so we're about halfway through. All right, so 5/8 inch diameter double braid, 1/2 inch diameter double braid. What's the difference? It's not that much. 5/8 is only 1/8 larger than a 1/2 inch. That's not very much. Or maybe it is. So why is it then that this 5/8 is like 50 or 60% higher rated than a 1/2 inch? What I want you to think about is the cross section of the rope. A 1/2 inch rope has 50% less rope fiber than a 5/8. Now, wait a minute, that doesn't make any sense. A 1/2 inch, how does that have 50% less compared to 5/8? Somebody brought up the question earlier about, calculating force. We're going to do a little bit of sciencey math here for a second. To calculate the area of a circle, we're going to use pi, that funny pi or the little squiggly sign, pi, times the radius, so half of it squared. So pi times r squared is the formula for area. But that squared is the really important part because it's not a linear, it's not a straight line growth in area, it's a curve. Where I'm going with that is that adding 1/8 in diameter adds 50% more area, and more importantly, 50% more fiber in this rope compared to the smaller diameter. And that's really important to understand. When you go up in rope size, you're adding a lot more material into the rope. You're not just making it thicker in diameter. And that's where energy absorption, that's where load rating comes from. That idea that what we call the cross-sectional area is so much larger, between 1/2 inch and 5/8, or 1/2 inch and 3/4. We have dramatically more rope fiber, which raises our capacity, raises our energy absorption. This is one of the details that's super important to understand. And if we take it the opposite direction, and somebody says, oh, hey, well, I'd really like a 5/8 inch rope, and we send them a 1/2 inch instead, we have significantly reduced the capacity of our rigging system by going to that smaller line. So choosing the rope based on its working load limit and understanding that increasing diameter greatly increases the amount of rope fiber, meaning larger forces can be handled safely, and it's more durable. So really important detail, a big concept, right? All right, so I wanted you to take that away from our section on ropes. And the question came up earlier about friction and using natural crotch or natural union rigging versus rigging through a block or a pulley. One thing that we're not going to get into today, but it's important to remind everyone of, and myself as well, is that some ropes handle friction better than others. A double braid rope like this is not designed for natural crotch rigging. Will it work in a pinch? Sure. But the wear and tear on the rope will be greater, and it will reduce its capacity because that interior braid will slip, whereas the exterior cover braid will catch in the union. So you'll actually compromise or reduce the rope's load handling ability as well as have more wear and tear. So if you do want to do natural crotch rigging, 3-strand ropes are great. Solid braids are good. Some of the coated ropes work pretty well. But realize if you use a double braid, whether it's a poly-poly type traditional double braid or a Kern mantle with a thin cover, you're going to have a lot of wear and tear, and you're going to reduce the capacity of your rope. And the behavior will be different too. All right, so let's switch into some knots for just a moment. And I want to show you one in particular. And it has to do with application, right? And choosing the right knot for the application. When we are rigging from above, typically, if we needed to tie off this piece, what would we tie? Well, I remember what I was originally taught was to put a 1/2 hitch in and then to tie a running bowline underneath it. It's a perfectly good application. That works really well. What I want to show you is the idea of what we would call midline rigging. Midline rigging is the idea that we are creating a tag line below the piece to give us additional control when we are lowering. If I tie a 1/2 hitch and a running bowline, like we talked about earlier, I'm going to adjust our camera a little bit. If we tie a 1/2 inch and a running bowline, in order to put a tag line underneath this, I need a second rope. But let me show you another option. The knot I want to talk about is the butterfly. Now, it's going to be a little hard to teach the butterfly, so I'm going to show it to you. And I'm going to suggest that you go check out animatedknots.com. Awesome demos on how to tie common knots. And the butterfly is absolutely on there. So animatedknots.com. The way I prefer to tie it is what I call the figure eight, or I've heard called the figure eight approach. Make a figure eight, double it over, and pass the bight through the middle. We're not going to spend time today on how to tie the knot. I want to show you the application of it. When we are rigging from above, we can create a tagline out of the rope that we're using by using a good, appropriate midline knot. So our butterfly is unique in that it can be loaded in 3 orientations. It can be loaded on the bight, and each leg of rope can be loaded, and they can be loaded equally. So we now have our load line, we have our tag line, we just need to attach it to the piece. So what am I going to use over here? Let's see. I'm going to use a carabiner and a sling. So let's talk about carabiners and hardware for a minute. When we're introducing carabiners into a rigging system, we want to use these in static controlled rigging. They're not ideal for a dynamic rigging, at least as a point of attachment, because too much can go wrong. Realize this is a device that's intended to be opened. So my preference, my recommendation to you is carabiners. Use them in static rigging from above scenarios. They can also be used in speed lines, controlled speed lines, those kinds of things. So we're going to use one here. I would encourage you to avoid aluminum carabiners. Steel's just much stronger. And certainly screw links can be used, but getting a screw link tight in the tree, having a wrench, I don't know, that's not terribly efficient. So steel carabiner, handy tool to have. And I carry a few different ones of different sizes and different configurations. So in this case, I'm going to use, I think this is a Sterling bark sling. Any type of rated sling could be appropriate for this. I'm going to choke it on our piece and clip the carabiner to our midline knot. And now what I have is a load line and a tag line made out of the single rope. And why is this important? 1, it's fewer ropes. 2, it gives me more control. And 3, interestingly, often this can reduce the number of people you need on the job. It's a great way to simplify rigging, have more control, make it easier to land the piece. Maybe you can land it with 1 person rather than 2. So I wanted to show you today, while we had the ropes out, show you the advantage or the opportunity to use midline rigging, choked with a sling, and a butterfly. There are other knots that look like this that do not behave the same way. I've seen people tie an overhand on a bight, a figure eight on a bight. Circus bowline is another knot you hear of. None of them are rated for this application. A butterfly is designed to be pulled in 3 different directions equally. So ideal for that kind of application. All right, let's move a few things here. All right, so let's talk slings for just a moment. We've got hardware out. We've got a few types of slings. We just looked at our chain sling. Let's talk about a few others. You've probably heard of and seen loopy slings, right? So this is an adjustable loop sling. Loopy slings are great for choking, whether it's the piece, choking the spar, choking something for a redirect, adjust the length you need. And here's the detail part. Choke it against the splice. This section is spliced with the rope passing inside of itself. So when we're going to choke, we choke against that splice. That's the detail that I want you to take away from talking about a loopy sling. The detail is when you're choking it on the piece or on the spar, choke it against the splice. That's when it bites most effectively and holds its length. If it's choked otherwise, it's just not going to perform up to the same level. So that's one kind of sling. Let's talk about another. I'll save my favorite to the last. Here's another one that's also spliced. You've probably seen something like this. This is a whoopee sling. So we have a fixed eye, or sometimes call it a dead eye, on one end. And then we have an adjustable eye on the other end. So we can change the length of this loop. Let's see if I can get that through. There we go. So it's choked, and then we have this extra tail that just goes out of the way. So this is an adjustable sling. Some people call it an adjustable eye sling. I'll tell you honestly, I've found these take a lot of material, and they're rarely the right length. I find I don't use them much, except maybe on the ground, using them for a ground level redirect, using it with a porter wrap, something like that. But I actually had to get this out of my extra gear box in the shop. I just don't use them very often, but some people really like them. So, the whoopee sling. I wanted to show you one other. You've probably all seen these, but this is sort of my pitch for a goodie, an oldie but a goodie. Some people call this a fixed eye sling, an eye sling, a dead eye sling. It's a spliced eye on one end. And a straight tail on the other. And why do I like this? You know, I used a lot of the adjustable slings in the past, whoopies and loopies and those kinds of things. So that's what was given to me. That's what I learned with. And what I discovered over time is that they were adjustable, but somehow they were still never the right length. I either had too short a sling and I had to get another. I had too much sling and I couldn't get it tight enough. And what I learned or found over time is that a dead eye sling like this is the best tool, in my experience, for tying something exactly the length you want it. Putting the block exactly where you want it, extending or shortening a redirect. Excuse me. So, a wonderful tool. And here's the detail. The detail goes back to our knots. All right, so when we're going to attach this, what knot are we going to tie? There's a lot of ways you could do it, but having enough length enables us to tie a cow hitch. And why do I like a cow hitch? Cow hitch is easy to tie. We get 2 wraps around the piece, and it can be untied easily after a heavy load. So our cow hitch is simple. Again, if you're not familiar with this, dig into it either in a good knots book or I believe it's on Animated Knots as well. Let me show it to you one time here. Around the back of the piece, and then changing directions, capturing the eye, back around the other side. We're a little low here. Let me change our camera. Let's see if that's better. Freaking it out. There we go. Around the piece, all the way back around. And you'll see that this sling is pretty long. This is like a 12-foot sling. But it doesn't matter. Okay, let's try one more time. Kale says I froze. So I'm around the back, and I'm going to capture the eye here in front. Go around the piece. There's my second turn around, and I'm going to pass it inside of the bite. This sling is really long. This is like a 12-foot sling, but it doesn't matter. I can tie this as tight and as short as I want, or I can tie it much larger on another piece of wood. This is a really easily adjusted knot. It gives me a lot of friction, and I can tie that knot exactly the way I want it. So here's one detail. When I am finishing my cow hitch, I've come through the bite with the working end. Where is that working end? There it is. I'm going to change directions. I came this way clockwise around. I'm going to change directions now that I'm through the bite and put a half hitch on. To finish my knot. Sometimes that's called a better half. Let me do that one more time and I'll show you what I mean. Finishing our cow hitch properly. We have passed it around the second time, come through the bite, and we're going to now change directions with the rope to make our half hitch at the end and finish the knot. It's the little details that are important to make sure that all your, whether it's your knots are secure, you've chosen the right hardware, your rigging system is dialed in to work as well, as efficiently, and as safely as it possibly can. It's having all the details correct. So a cow hitch, great knot for attaching a porter wrap, great knot for putting a block onto the tree. Another place a cow hitch is really, really good is on a spider leg for crane rigging. Because I can load this really heavily. I can pick up thousands of pounds and still untie the knot easily. All I have to do is release my half hitch and it all will come apart. And here's another detail. A knot that looks similar but behaves differently is it's a clove hitch. I could certainly tie a clove hitch on there. In a static rigging from above scenario, a clove hitch is a great knot. It's really secure. But if you've ever tried a clove hitch with a really heavy piece, or in dynamic rigging, or in a crane pick, untying a clove hitch after being heavily loaded is super difficult. So a cow hitch is an excellent knot, super functional, and combined with a dead eye or fixed eye sling, you've got a really good combination of tools and knot for. Hey, we're back. Right on. Hey, thanks for bearing with us. Technology, right? Who knows? All right. So we've talked about knots, rope construction. We've talked about slings. We've talked about steel carabiners. Whew. We've talked about a lot of things. Let's do this. Let's take a couple of questions. We got about 40 minutes or so left. Let's take a few questions now, then we'll do one more good section.
Okay, right. Questions coming on up. First of all, we've got a couple people in the comment section asking if you are related to Bill Nye.
No, but we're both very handsome.
Okay. I've got here one from Ladson Pool the Fourth. If you have to purchase one size of rigging line, what would you go with?
Ladson, that's an awesome question. If I had to purchase one size. So, I'm going to have to tap out on that question. I just don't think I could answer that. And let me explain why. When I'm thinking about purchasing a rigging line, whether it's my first or my fifth, there's a few questions I need to answer for myself. What kind of work am I going to do? How high in the tree will it be? What size material will I be moving or rigging? And what kinds of rigging configurations will it be? Is this going to be static rigging or dynamic? Am I rigging from above or below? Is this a speed line? Is this something that's going to be a pull rope for felling? All of those push me one direction or another. Can all of our rigging be done with 3-strand? Probably yes. But it's far more efficient if you have a couple of different lines to choose from. I will give you one suggestion. I think some of the 12-strand solid braids are in many ways a bit of a do-it-all line. True Blue's been around a long time. That line will handle an awful lot, and it's rated quite high for its diameter. That's one to consider if you could only buy one line, but realize it's not going to do everything well. So it's a great question. I wish I had a better answer, but hopefully those are some questions you can use as you're considering what line is best suited for you.
I just want to say also if anyone is having any problems coming up with what kind of line they want to choose, you can always email rope@treestuff.com, and that will get you to somebody who knows a lot about rope and who can give you a better recommendation for that. So you might be getting Nick Bonner, who can tell you more about rope than I've ever known, or we can send you straight to the manufacturers.
Awesome.
Here's another one. I think Victor Lazar's was trying to get you off on a different tangent, but it is related. I know you could probably talk about this for an hour.
I like tangents.
Do you have any rough math on calculating the torque generated when you're rigging?
Ooh, yes. And it is outside of what we're going to have time to handle today. So a couple of answers. One, and Cale, maybe you can share the link to the micro rigging lab that I did back at Expo last year. 2019 Expo, we did a micro rigging lab talking about torque and leverage. Also, there's a terrific article by
hold on. By whom?
And rigging by Joe Harris.
Joe Harris. Okay.
Yep, it's called Working the Angles. If you Google Working the Angles, Joe Harris, you'll find that article. Super, super great article. Thank you for the question, Victor. It's going to be beyond what we can address today.
Okay. Let's see. Another one. Oh, yes, the micro rigging lab videos that he's talking about. You can find those if you go to TreeStuff. Up at the top where there's the main navigation area, right underneath the search bar, you'll see Shop Talk, and all of our videos, our educational videos, are posted there from the last couple years, and you can find that just by looking for the micro rigging lab.
Awesome.
Let's see, that's the torque generated. Have you ever broken a rigging line?
Ooh, great question. Have I ever broken a rigging line? No.
Easy.
No,
easy
and let me give a let me expand on that very briefly. No, I don't believe I've ever come close to it. 100-pound pieces through the air and been close to the working load limit on the line. I know others have broken them. Terrified by that thought.
Hold up. I don't know why you're... okay.
Oh, okay, I don't know where we got cut off, but I've never broken a rigging line. I don't believe I've ever come close. I've put some pretty big pieces on ropes dynamically, big trees as well, who have broken ropes, and I'd sure be curious to know the history about how that happened. Personally, never have. Hope to never do so.
There's a lot of interest in hearing you talk about rigging rings. Ladson Poole is asking, how do you feel about using rigging rings in place of an arborist block? And then we've also had a few requests to talk about bend radius.
Yeah, great questions. How do I feel about using rings in place of a block? I don't typically do it. I'm not really a ring guy. Both of these that I have, I use primarily for redirects on the ground. We can talk about that in a few minutes. I don't use them in the tree, very often at least. I'm trying to think through my reason why. I'm going to tell you I don't have a good reason. I think my personal feeling is I have a high degree of confidence in the blocks that I own and that I'm used to using, and I haven't yet been convinced to switch. That's probably non-scientific, but that's the real answer. All right, so here's something that comes up. Speaking of ropes and sending things into the tree, I want to talk about tying knots for a second and tying one line to another. When we're tying to a piece, for instance, a piece of wood, we're going to tie a knot that's often referred to as a hitch, right? A cow hitch, a clove hitch. When we're going to tie two ropes together, we're going to tie what's called a bend. And particularly, I want you to be familiar with the sheet bend. Whether you're sending up a second rigging line, whether you're tying onto the climber's line, this has been on my mind recently as I've had a new ground person working with us, how to send things up in the tree. And the knot that I want to show you, as I mentioned earlier, is called the sheet bend. And what's really important about a sheet bend is it works great for tying together two ropes, even a rope and a chain. God forbid we need one in the tree, but a rope and a chain of greatly different diameters. So I have my 1/4 inch line here, and I have my 1/2 inch line here. Again, animated knots is going to be your friend for looking up how to tie them, but I will show you here. Sheet bend, start with a bite in the hanging rope, the rope that's in the tree. Take line, pass it up through the bite, around the back. So I'm through the bite and around the back, and then underneath itself. It's a really simple knot, but it's something I find many people are not familiar with. A sheet bend. It's designed for tying together two ropes or a rope and a chain of different diameters. Other knots may come loose, they may slip. You might drop a rope out of a tree, and it's not necessarily that it's going to damage anything, but it just becomes really inefficient. So having this knot in your mental toolkit, this sheet bend that you can use to send up a large rope attached to a small rope with a lot of security, it's a great tool in the toolkit. And if you're feeling really fancy, I'll show you one upgrade for it as well. If I use a little bit more working end, say a couple of feet, I have my sheet bend started. I went up through the bite, passed around the back. I can pass a bite underneath itself. This is a really nice upgrade. Instead of putting the working end through, we just passed a bite through, and we have what's called a slippery sheet bend. This is great from a climber's perspective because once the rope comes up into the tree, I can pull on the end, and now the knots have come apart. I don't need two hands to untie it. So a sheet bend and a slippery sheet bend, just modifications, one or the other. Great for sending up large diameter ropes, actually really any rope, but particularly large diameter ropes in the tree. Tie it one more time and just let it hang there. Animated knots is your friend for seeing more detail on how to tie these. So great little detail here. All right, so where are we going next? Friction, that's right. How are we on time? Perfect, we've got about a half hour. So let's talk about friction in the tree. A question had come up earlier about natural crotch rigging or natural union rigging. You remember the story I told about early on. I was concerned about trying to get friction out everywhere. And what I learned is friction is one of the key ways we dissipate energy. We talked about rope elongation, energy absorption there, but we use friction to dissipate energy. So let's set up a little rigging scenario back here and talk about where our friction is. I think we're hearing Cale's cat in the background. He said his wife was there too, but I think that's the cat. All right. That's my way of telling Cale that his microphone is not muted. Cale is learning today just like we are. All right, so I've got my cow hitch tied. We are rigging from above here, and you can't really see the block, an omni block tied up in the roof of my deck here. And then I have a porter wrap back here. So if I set up my rigging line, the fall of the rope in the porter wrap, and I don't know, I'm going to put a couple of wraps on just for sake of argument. To lower this piece, if I have a low friction block in the tree, all of the energy from the movement of this piece is transferred through the line, through the block, to the porter wrap. So for the sake of argument, let's say I needed 2 wraps to lower this piece. That's neither good nor bad. It's just information, right? I've got 2 wraps here on my porter wrap. I'm going to lower X piece, a piece of whatever weight. What's the downside of that? Well, one is I'm multiplying force. Remember our conversation about low friction, putting 2 legs of rope together multiplies the force in the tree. So when I have low friction at my rigging point, I am multiplying force there. So I'm putting more force in the tree. because all the friction's here at the ground. Instead, if I used maybe a combination of rings in the tree, I used a natural union, I used some type of friction device in the tree, maybe it's a rigging wrench, I'm going to reduce the overall force for holding that piece. If I can put friction in the tree, our multiplication is diminished. How do you know that's the case? Well, some of you have probably been through this experience where you've been rigging off of a particular rigging point, off of a block, and then the climber or the bucket operator has put in a natural redirect, taking a similar size piece, and all of a sudden your 2 wraps are way too much, and the piece won't lower. You got to flip off a wrap, and now you're down to 1 wrap, and you can lower it. Well, why is that? Because our natural redirect out here is absorbing energy. That friction is helping dissipate energy in our rigging system. So some energy is dissipated at the natural redirect and some at the porter wrap, rather than all of it being here. So friction is your friend, and the key is to put it where you need it. And I want to share with you an idea, and it goes back to the rings question. I do a lot of tree preservation. We do a lot of pruning, deadwood removal, hazard mitigation, trying to retain trees. So we're often rigging in a tree where we can't cut everything out of the way. We need to keep as much as possible. And we also have a lot of targets underneath, typically. And we're working with a small crew. Typically, there's 2 or 3 of us. Anything we can do to simplify bringing down material in a safe and controlled manner makes our lives easier, helps prevent property damage, and makes the whole operation smoother. You remember earlier that I showed you that midline knot with a butterfly and a sling attachment. Well, that's one tool. The other that we use is putting friction in the tree. And whether it is natural crotch rigging, I've actually spliced a steel ring friction saver, or used a steel ring and ring friction saver to create some friction and make a retrievable rigging point, all for light duty rigging. But what's interesting with any of these options, maybe it's rings, anything that adds friction in the tree, rigging wrench for instance, is that as the piece is being lowered, the person on the ground is holding the running end of the rope. Maybe they need to land the piece, and I, as the climber, can change my position. And because the friction's up in the tree, now I can hold the rope while I'm in the tree and lower the piece, and the person on the ground can let go and focus on landing it. And maybe it's walking it around a fountain, maybe it's laying it down on a garden pathway, whatever it might be. Putting friction up in the tree rather than at the ground in appropriate rigging scenarios, right? But that enables us to perform work often with fewer people on the job. And let me show you what the alternative would be. If we used our porter wrap or any other ground or basal friction device, one person's going to be over here running the device. And maybe they can redirect and they have some flexibility to move, but they certainly aren't going to go around the corner of the house. That wouldn't make any sense. So we need a 3rd person now over there. I'm up in the tree, somebody's running the porter wrap, and the 3rd person is around the house landing. But what if instead, like we talked about, we put friction up in the tree so that I, as the climber, can help run the rope? I've made the cut, the piece is partway down, I transfer over, I'll run the rope now, and the grounds person can walk around the house and land the piece. It's a really interesting way to dial in your rigging to make the job easier, safer, efficient. Is it appropriate in every application? No, of course not. But when you're dealing with a lot of targets and moderate size pieces, get your friction right up in the tree, and all of a sudden you can work as a team, trading responsibilities, landing pieces, and doing with 2 people often do or would often require 3. So a great advantage of friction in the tree. Rings can be part of that solution, rig and wrench, natural crotch, all kinds of different solutions, rather than a low friction block. Let's turn that around for a second. Remembering the detail here. When we have low friction up in the tree, what is that good for? That's really good for raising. If we're going to use a GRCS, if we're going to use a porta wrap with mechanical advantage, if we need to raise a piece, what do we want? We want very low friction, and we want a static type rope, a low elongation rope. So understanding your scenario, what type of rigging you're going to do, static or dynamic, what are the piece weights, and then what are the tools you have available enables you to dial in your rigging system to do exactly what you need to work safely and to work efficiently. All right, so let's talk about porta wrap here for a few minutes, and then we'll take a last group of questions, because this is leading us just to the right place. So one of the challenges with a porta wrap is terminology. And I use the porta wrap term generally. There's a bunch of devices that look roughly like this. Right, so I'm here at the base of our tree. I have my porta wrap attached with a cow hitch. We have our piece here. We have a low friction block rigging point. And I'm going to set some wraps on the porta wrap. And let's talk about terminology. And I've got another porta wrap somewhere here. Nope, we're going to use this one. That one's not going to come off. All right. So on our porta wrap, we have a few different things that we need to be aware of. One is we have this loop at the bottom where the sling attaches. That's coincidentally called the sling loop. What a surprise, right? At the top, the other end of the loop, we call the retention loop. All right, so sling loop, retention loop. In the middle, the cross piece here is called the barrel. And then we have these parts that point out of it, the pins, and they have two different names. On the short end, where we feed the rope through, this is the retention pin. On the long end, where we run the rope, these are called the cleat pins. Think of a cleat on a boat. So when we set up the rope in the porta wrap, using these terms is really important. So we all are clear on what we're talking about. So I'm going to feed a bite of rope through the retention loop and over or around the retention pin in the back. That way it cannot slip off. So in a porta wrap, bite is through the retention loop, around the end of the barrel, and over or around the retention pin. That is our minimum configuration. That is our minimum friction. So the question is, how many wraps is this? This is where the details go wrong. You remember my story early on about being on the job and switching ropes and rigging wood and the person on the ground going all Superman? This is where we went wrong. We miscommunicated about the number of wraps. I asked for one thing, the person on the ground thought they had done so, and we miscommunicated. It was my fault as much as anyone else's. So when we have this set up, when we're around just the retention pin, that is 1/2 wrap. That is our minimum friction on a porta wrap. And when we're running that, we run it with the rope against the cleat pin, not bent down here, against the cleat pin. So it keeps the rope in the proper orientation. So let's take it a little farther. When we are adding wraps, we're going to continue the direction that we are wrapping the rope based on however we put it around the barrel and over the retention pin. So for me, I'm going counterclockwise or anti-clockwise for those of you in Europe and Australia, New Zealand. We're going anti-clockwise. Every time I pass underneath the barrel, I have completed a full wrap. So to start, around the back, that's 1/2. Underneath, that's a full wrap. Once I get to the top of cleat pin, that's another 1/2 wrap. Underneath one more time, that's a second full wrap. So when you're communicating, if you're in the tree or in the lift truck, and you're talking with your ground crew, whoever's running ropes, it's important that you both have the same understanding and use the same terminology for how much friction, how many reps are in your lowering device. Do you need minimum friction? Just a half rep? I've heard some people call that around the horn. Who knows what that really means though? We are in the device, we're around the retention pin, we have minimum friction, we have 1/2 rep. Those are accurate terms. Or do we need a full wrap? Or 2 full wraps? Or 3 full wraps? Or just 2.5? That extra half wrap makes a small difference, but it's measurable, it's meaningful. So what I implore you to do is be clear, train your crews, and get everybody on the same page with how many reps you're putting on that lowering device so that you know what's going to happen. I want to talk about body position with this too. So I've set this up. Let's assume this is a dynamic scenario. I realize that's not what it shows over here, but let's assume it's dynamic. And let's say the climber's called for 1.5 reps. That's what I've got. Everybody knows what water skiing is, I think, right? Where you're behind the boat and they're pulling water. This is water skiing position. Don't do that. It's such a bad idea, and let me tell you why. If I'm in this position, leaned back and pulling really hard, why am I doing that? I'm doing that really worried. I'm worried that my partner in the tree doesn't have a good understanding of the piece weight. Or maybe I don't have the right number of reps. Or I'm stressed out, something's going to go wrong. So I'm hoping somehow my grip strength, my arms, shoulders, my back, my body weight are going to compensate. And guess what? It just ain't going to work. So anytime you come on a job site, or if you're up in the tree or in the lift, and you look down and you see your ground person leaned back on the rope, stop. Because something is about to go wrong. Because somebody's not communicated or somebody doesn't understand how this is supposed to work. When you're running the porta wrap, 1, get your rope bag, put it off 90 degrees to where you're standing. 2, get farther away from the porta wrap. Obviously, I'm going to go out of the frame, so I'm not going to go too far. And 3, the right amount of friction allows me to control this just with the friction of my hands. This is not an arms full body action. If I want it to run, I loosen my grip. If I want it to stop, I grip the rope more snugly, more securely. Let me say that again. The difference between running and stopping the piece is grip and forearm strength. It's not shoulders and back and full body. We're not water skiing here. When I say dial in the details, what we've been talking about today, about understanding the piece weight, understanding the force that's going to be created, the type of rigging, using the right rope, communicating about the number of reps, it's my hope, it's my expectation that with what we're talking about, and you apply this on the job site, train your crews, that you can have the level of precision in your rigging that we just talked about, which is you're controlling run and stop in the piece merely with grip strength. That's all we need. But I'm missing something important here. What am I not wearing right now? I'm not wearing gloves. And I can't miss the opportunity to talk about this. I love climbing in those rubber-coated latex, whatever they're made out of, Atlas gloves. They're awesome. I've got big hands. They help take up some space on thin ropes. Great grip. They're wonderful. But they're the worst for running ropes on the ground. If I'm going to run ropes, I keep a pair of leather gloves in the truck. When I'm going to run this and I want to let that piece run, if I want movement in a dynamic system, I want it to slide through my hand and then grip the rope and it comes to a nice, gentle stop. That's super important. I know people who say, oh, I got tough hands, it doesn't matter. That's a nice idea and all, and maybe it's true for somebody, but as soon as that rope picks up a thorn or a splinter and it comes ripping through your hand as you're running a 500 or 1,000-pound piece over somebody's roof and you say, ouch, and let go, it's all gone badly, all because you didn't have a $10 pair of leather gloves. So make sure you got a pair of leather gloves when you're running ropes. They're an awesome tool, gives you control, gives you adjustability. They wear really well, they're cheap, and it adds to safety on the job site. All right, lots of little details like that. Whew, we're just about to the end here. Looking at my notes real quickly. One more piece I want to share. Ooh, perfect timing. The one downside of a rigging device attached to the tree is it's easy to be in the drop zone. To lower a piece, have a piece run, and have it come very close to you or the person running the rope. I know friends who have been hit under the tree when things have gone wrong. So what can we do to get you away from the tree? How can we increase safety on the job site, increase safety in rigging? Let me show you a simple addition. I'm going to take our porter wrap off the tree, untie my cow hitch, and I'm going to put something else in its place. Don't want to undo the bungees that take my tree apart. That'll be bad. All right. So I'm going to take my porter wrap off, and I'm going to move it. And I'm feeling really clever right now. I wonder if you can see it. Back here on my other tree, I already have my other porter wrap set up. So imagine that I took the porter wrap off the first tree and I moved it back over here. Now, if I run this angle with the rope, this is going to do all kinds of strange things to my rigging point. So I don't want to run the rope out here, redirect it. So, who was it, Kale, that had asked the question about rings? Oh, you didn't know. So anyway, I apologize to whoever it was that asked the question about rings. I'm going to show you the one thing I don't like about rings. Where's my ring? Here we go. Ring sling. I like to daisy chain them. If I want to add a redirect into my system using a ring, what do I have to do with my rope? I got to pass the darn thing through the ring. It's not midline attachable. Rings are great. They're durable. They're lightweight. They're wonderful, but they're just not midline attachable. So let's do that. The lesson in this is if you're going to use a ring, set it up early. So I'm going to tie my cow hitch again. Back through the bite. Changing directions for my half hitch. And then I'm going to pass my rope, my rigging line up through the ring. And then I'm going to step out of the frame just a little bit. Pass this through the block in my very short tree. Works out pretty well. Tie a slip knot so I don't lose my line. Ooh, there's a detail. Do you ever do this? You tie a slip knot so that when it runs up, it stops against the block and the line doesn't fall out of the tree. Super handy. So now I have a redirect at the base of the tree, and I can take my rope bag and the rest of my rope to a porter wrap located away from the tree or another lowering device. And now I can run it over here, and I am out of the drop zone. It's a great application for a ring, but you got to set it up early. The reason I like a ring here is if something goes wrong or the piece lands on it, smashes it, I'd much rather replace a ring than a block. And it's lightweight. It's easy to add into the kit, but you do have to pass the rope through it either on the way up or the way down. For me, that was the short end of the rope, so I did it that way. So that's a detail, and I want to give Mark Preshkarat of Fids and Fibers due credit for convincing me that this is a good idea. I'd never done it before a few years ago or not done it regularly, and he changed my mind about it. So learn something all the time, right? And Mark's a good friend, and I appreciate his input on that. So hopefully that will be helpful to you as well. All these little details that we've talked about, gosh, it's a whole long list of things, right? We've talked about understanding rope construction and elongation. We've talked about that order of rigging operations. Can we fell it? Can we free fall it? Can we rig from above in a static way or rig from below dynamically? That's our last choice, right? Because we introduce energy into the system. We've talked about knots. We've talked about attaching rope to rope with a sheet bend. We've talked about midline knot, using a butterfly to use one rope and have a tag line. Pardon me. Talked about different kinds of slings, blocks and pulleys, carabiners, terminology on a porta wrap, that retention pin, remember, and minimum friction, a half wrap versus a full wrap, and communicating and using the same terminology with your crew. We've talked about the fact that friction is always there. It's movable, it's adjustable. Put it where you need it, manage it, let it work for you rather than against you. And talked about redirecting at the base of the tree. All of these details going together to increase your efficiency, increase the safety, and I hope increase fun of rigging and removal jobs. I like preserving trees. It's really important for our environment and our community, but rigging and removal is fun too. So that's what I have for you today. Cale, let's take a last group of questions. Please, I welcome any questions you have. We've got about 10 minutes or so. Let's see if we can hit a few really good questions and wrap up on a high note.
Yeah, I have a few really good questions I like here. One of them, Clayton Luttrell is asking, when talking about the porta wrap and dialing in the friction that you want on that, how does the friction increase as you add a wrap?
Great question. How does the friction increase as you add a wrap? I'm going to give you, again, a tree guy mathematical answer. And I wish somebody would publish data on this. But the way I generally look at it is that in a rigging from below, a dynamic rigging scenario, Clayton, I generally figure that a half-inch line, one wrap is good for about 300 pounds of piece weight. Maybe that's a funny way to say it. Let me try it for you one more time. Rigging from below, right, when our piece is above the block, I generally figure that something in the 250 to 300 pounds piece weight, not load, is suitable for one wrap on a half-inch rope. And as I add a second wrap, or a half a wrap, I work in that similar increment of maybe 250 to 300 pounds. So if I got a 500-pound piece, I'm kind of getting up into the 2 wraps-ish, maybe 2.5. And the guideline that I'd like to give you, and this is just personal experience, I've never seen this published anywhere, but in my own experience, talking with other people, when I was doing a bunch of safety work down in California with big trees, a lot of negative rigging, is that once you get to 2 wraps and you start thinking about wrap number 3, I think you need to ask yourself, do I have a large enough rope, or do I need to go up a diameter or 2? If I've got a half-inch rope and I got 2 wraps, before I go to a 3rd wrap, maybe I need to think about going to 9/16 or going to 5/8. Because putting 3 wraps on, 4 wraps on, your question, Clayton, leads me to say, as you get into 3 or 4 wraps, the rope tends to bind rather than run smoothly. So in a dynamic scenario, 2 wraps, 2.5, I find that's about the limit before I switch ropes. Now, I have been in a situation where we had 3/4 inch ropes with 4 wraps, and I just don't want to do that again. It all went well, but that was extremely stressful. And so once you hit 2 wraps, think about a larger diameter rope. That may not have been exactly the question you were asking, but I hope it's helpful.
No, I think that was a great answer to that. Sticking on porta wraps here, Aj Rubal asked, what is the recommended distance from the porta wrap for your ground guy?
Ooh, that's a great question. What is the recommended distance? I'm going to tell you, I don't know an official type answer to that. Some of it is site dependent. I would tell you the simple answer is outside the drop zone. probably the best standard to work with would be as if you were felling a tree, that you want to be 1.5 times the length of the piece away from the landing point. So if you got a 10-foot piece, be 15 feet away. That may not be easily translated because of the environments we work in, but typically, farther is better. Get away from that drop zone. Great question.
All right, another question. Josh Vibes asking, what is the half zip that you're wearing?
Oh, this is one of my favorite shirts, Josh. I don't remember the name, so you'll pardon me. This is from TreeWork out of Colorado. It's just a lightweight shell. It's comfortable, and I don't know the name, but I love it. So it's made by TreeWork. Check it out.
Okay, great. Moving on. Hold on. Where you start asking questions and answering questions, and then more questions start flooding in.
And Kale's brain melts.
Yeah, exactly. Aaron Rickenberg, recommendations for cleaning and storage for rope.
Ooh, cleaning and storage for rope. I'm going to answer it with sending you somewhere else for information. Teufelberger just shared maybe 4 or 5 weeks ago some interesting data around rope cleaning, different types of cleaning products, and the impact around or impact on rope strength. So check that out. I don't remember where the link is or what it was. Teufelberger's website, I'm sure, has that. Rope storage. I'm a rope bag guy. I don't know how to show you this, but I've got 5 rope bags out here right now. I don't care what brand they are as long as they're durable. Breathable. Don't like waterproof rope bags. I've got a big haul bag for my climbing gear to keep stuff dry on the job and in the truck. But with rope bags, I want them to breathe so that if there is moisture, it can come out. And get a big enough rope bag that's appropriate for the length of line. Don't put 300 feet of half-inch rope in a small rope bag. You'll wish you hadn't. So that's my thought.
Perfect. And I just want to say that if you're looking for durable, cheap bag, TreeStuff, what is it called now? I think it's called the Improved Simple Rope Bag, and there's also a bull rope version. You really can't get better quality for better value than that. Daniel Ruiz again. When using the butterfly as a tagline, can you use it to pull the tree over also, or is it just to control your piece?
Ooh, in your question, Daniel, I'm assuming that you are trying to pull the tree over. Great question. If you're going to put a winch or a serious mechanical advantage into the system, a butterfly will get very, very tight. You can tighten it to the point that it will no longer untie. So a butterfly is ideal when you are going to pull in 3 directions. If you're only going to pull in 2, there are other other knots to choose. We spoke earlier about what sometimes is called the circus bowline, the 3-ring circus bowline. That is a 2-directional knot, ideal for use with a winch. A bowline on a bite is great for midline attachment with a winch or mechanical advantage. A butterfly creates that tag line, but if you're putting a machine on it, a winch, mechanical advantage, you can turn that into what I've heard called a hatchet knot or a knife knot. So just be careful at how much force you put into it.
Okay. Another one here. You talked about loopies, whoopies, and our fixed eye slings. Phil Renaud noticed that you weren't talking about the ultra sling at all. So what's your thought on that?
Yeah, it's a great question. What do I think of ultra slings? I had several ultra slings. I thought they were cool, and then I found they were always the wrong length. Let's make sure we're talking about the same thing. An ultra sling has multiple sort of spliced pockets. Okay? It's not a sewn chain, but is a spliced sling with multiple pockets that you can tuck the block or the ring through. I found that my block or my ring always hung down 6 or 8 inches beyond where I want it, or didn't quite reach. So I found it was adjustable in increments that were too large. I tend to be maybe a little bit OCD about trying to dial things in perfectly. I find a fixed eye or a dead eye sling gets me exactly what I want. An ultra sling might be a little faster, but I found it to be less precise. Just my personal experience.
Okay, I think we can do one more here.
Yeah, please.
Actually, we'll do 2 more. because we didn't actually get to this one. Blair Glenn asking about wet rope and friction on your
Oh
quarter
yeah,
wrap
great
and-
question.
Yeah.
I'm going to give you a non-scientific personal experience answer, Blair. I have found when ropes are wet that they tend to be jerky and the friction is inconsistent. If I need a piece to run smoothly in a dynamic rigging scenario, rigging from below, a wet rope is a huge pain. It tends to grip and stick rather than run smoothly on the porta wrap. That's my own experience.
How would you mitigate that? Do you have any ways, or is that just
how
something
do
you're
I
dealing with?
how do I mitigate that? Yeah, I have an idea. You could potentially add friction to other points in the system and therefore reduce the number of wraps you need on the porta wrap. If I put a couple of rings in or put a natural redirect or something like that, I would reduce the friction needed at the lowering device, and that might allow it to run more smoothly. You could also get another rope.
Perfect. Okay. And our last one, I think that we'll end on.
Yeah.
We've had a little bit of an international dispute here. Is Canadian bacon ham or just bacon? What's your view on this? The Canadian bacon.
I have the best possible answer.
Okay.
I'm vegan. You're asking the wrong dude.
Oh, that's true. Okay. All right. Well, thank you very much.
None of the above. Thank you, Cale, and a big thank you, everybody, to Cale Royer, to Nick Bonner, to TreeStuff for making this possible. It's such an honor to be here with all of you, sharing my experiences, paying it forward, what I've learned from other people, and I really appreciate your questions. I look forward to seeing you in person and making new friends next time we can all get together. Get out there and vote. Live up to your responsibility, you Americans. And thank you for taking the time to be here. Peace.